In the 1900s, Max Planck introduced his constant in a formula explaining the light radiation emitted from heated bodies. He postulated that energy can only be emitted or absorbed in discrete amounts, which he called quanta. The energy quantum is related to the frequency of the light by a new fundamental constant, h. When a body is heated, its radiant energy in a particular frequency range is, according to classical theory, proportional to the temperature of the body. With Planck's hypothesis, however, the radiation can only occur in quantum amounts of energy. In 1905, Albert Einstein created the quantum theory of light, which is the idea that light exists as tiny packets or particles, which he called photons. Einstein proposed that we live in a quantum universe, one built out of energy and matter. He published 2 papers. In one, he invented a new method of counting and determining the size of the atoms or molecules in a given space. He proved atoms exist. In 1913, Niels Bohr proposed his quantized shells model of the atom to explain how electrons can have stable orbits around the nucleus. The motion of the electrons in the Rutherford model was unstable because, according to classical mechanics and electromagnetic theory, any charged particle moving on a curved path emits electromagnetic radiation. Thus, the electrons would lose energy and spiral into the nucleus. Bohr modified the Rutherford model by requiring that the electrons move in orbits of fixed size and energy. Using Planck's constant, Bohr obtained an accurate formula for the energy levels of the hydrogen atom. In 1925, Werner Heisenberg discovered the uncertainty principle. This means that electrons do not travel in neat orbits, and all electrons that contain photons will change momentum. He contributed to the atomic theory by calculating the behavior of electrons and subatomic particles that make up an atom. His discovery helped clarify the modern view of the atom because scientists can compare the actually few numbers of atoms there are. In 1926, Ernst Schrödinger combined the equations for the behavior of waves with the de Broglie equation to create a mathematical model for the distribution of electrons in an atom. The Schrödinger model assumes that the electron is a wave and tries to describe the regions in orbitals where electrons are most likely to be found. It describes the probability that an electron can be found in a given region of space at a given time. His model allowed the electron to occupy 3-dimensional space.